So recording. So I'm going to create a myself. New class local. Then new class cat. Finish. And new class pupil. And new class phone. Alright, so we go to the local class. So dealing here to scopes of variables. Now, so first type of variables. I'm going to go private string name is equal to Mary and protected string address is equal to Galway. Right, so put a comment above them here. These are instance variables, or it's called attributes, i.e. age, weight, height, etc. So we say variable name is available the full length of the class. Okay, so that means that name and address are available everywhere within the local class. Yes. Okay. What you say is it's available the full length of the class. Okay. A instance variable is always longer, so we say, than a local variable or a method parameter. Name and address is available anywhere in the local class. Now, access modifiers, private, protected, public, do not affect the scope of the variable. Okay. The string variable name is private and is still available throughout the local class. Okay. These access modifiers, okay, these access modifiers are only to do with access outside of the class. Okay. Now, if you have inner classes, there's a slightly more complicating factor there, but we're not dealing with inner classes. Okay. So this private string name Mary doesn't affect the scope. The scope is that this guy, Mary, is available everywhere within this bracket and this bracket. Does everyone understand that? Okay. So an instance variable, when we say it's available the length of the local class, that's the term we use. Is that okay, everyone? Similar for address is also available the length of the class. Now, lest there be any confusion, if I have a method up here, right, and I go inside here, I just access the name. Okay, it doesn't matter where you declare the variable, the instance variable in the class, it'll be available throughout it. Alright, you could even declare that variable at the very end of your file. Okay, you could declare these two variables at the very end of your class, that'll still be available throughout the class. Does everyone understand that? Okay, so where you declare them does not matter.
Because it's a class, if it's a method, then the
Yes. Okay. Now, so let's put in here. Where you declare a attribute does not matter. Okay. It is still available throughout the class. Now, you usually declare your variables at the top of the class. Why?
It's very easy. You go straight to that region.
Yeah.
Familiarity.
So you look at the top. You're starting off your class at the top. Now, you should declare all your variables at the top of your file. Now, you will find as you're going along, you'll say, oh, geez, there might be another variable there. All right? And you can declare the variable in the middle of your class. I would still advise you to put the variable at the top of the class. Okay? Because you're starting off, you're creating a person. A person is going to have a name, an age, a weight, and a height. Okay? It's logical to put them at the top of your class. You don't have to. You can intersperse them throughout your class. And as soon as so that's the rule for attributes. It's a different rule for local variables. Okay?
Just one question there on line 6. No, it's probably right.
Line 6.
Yeah. Did you ever put name?
Oh shit. That should be name.
Yeah, that's
Okay?
so, okay, I just want
yeah. Okay? So it does not matter where you declare them. Now, however, you usually declare your attributes of a class at the top of your class. But you don't have to, but it makes sense to do it.
No, did that not come up with an error when the quotes were around? Did I read?
No,
No, just.
it's just going to print off name.
Just name. Okay, sorry.
Okay? So, now, so, other type. So, if I do static int course ID is equal to, now, put this one here. Now, these are called, static variables are also called class variables. Alright, so, class variables or static variables belong to a class, not to an individual object. A class variable is shared across all objects, i.e. everyone in this course has the same course ID. So there is only one copy per class of this variable. Whereas with an instance variable, every object has its own copy, i.e. every person has an age, weight, height, etc. Now, so we're going to show you local variables. So we're going to create a method called void access local int num. Open bracket, curly bracket, close curly bracket. Now, so put on this one. So the method parameter int num can only be as long as the method access local. Okay, so we can only access num inside from here to here. Okay, so a method parameter is a variable that's local to a method. Okay, so put it in here. Num is available only in the access local method. Now, so inside here, so we're going to send a number to the method, and inside the method we just do something very simple. We double it. Okay, so just say we did. The number sent to the method is now doubled. Now, inside here, I'm going to create two variables. They're both can be doubles. dnum is equal to 24. Double num is equal to 4.5. Now, so this is a local variable. Whenever you declare a variable inside the method, now it's not actually inside the method, it's inside brackets. So local, what determines something is a local variable? A local variable is a variable now this can be brackets for a method, a loop, a enum, a inner class. Sorry, it's curly brackets as well, by the way. Sorry, it's like curly brackets. So inside a method, a loop, an enum, an inner class, an if, else, so on and so forth, else if. Okay, so all of those use curly brackets. So if you declare a variable inside those curly brackets, it's a local variable. Okay, now, so this is a local variable. that is available from this point onwards only in the access local method. Okay, local variables can be as long as a method parameter, but never longer. Now,
Well, you use it like double and Luna. You want probably
number. Now, locals aren't like attributes. Attributes of a class, you can declare them anywhere in the class, and then they're available everywhere in the class. Okay. Local variables, denum is only available from this point onwards. Okay. Double number is only available from this point onwards. So in this case, num is longer than denum because num is available up here. If I declared double denum up here, that would mean that denum is as long as num. Okay? But it isn't because there's a line of code up here. This means that, so over here, we have a line of code before we declare these variables. That means that num is longer than denum and double number. Okay, so with attributes you can declare them as long as outside the bracket. You can declare them anywhere in your class. Okay, with local and they can be accessible then anywhere within your class. With local variables, they're only available after you declare them. Okay, if I try to access denum before here, I get an error. Okay, that's not the case with attributes. I declare an attribute down here. Let's see, what attributes do I have? Name. So I'll have an attribute called int age. That's available now. Int age is equal to 67. Okay, that's available in here. Okay, so an attribute can be accessed anywhere, whereas a local variable can only be accessed after it's first declared. Okay, so just take that out there for now. So we cannot access denum before we create it. Forward, now this is called forward, what's the term again? It's forward referencing. Is not allowed for local variables. Okay, forward referencing is not allowed for local variables, so you can only access denum after you create it. Okay, is that okay, everyone? Right. Now, so now we can access inside here. So we've got three variables now. I put the variables in funny locations just to show that you can. So I have got a name, I've got an address, I've got a static, and I've got an age. Okay, so I can access all of these variables anywhere. Okay, so we can access any attributes in this, any attributes of the local class in this method. Okay, so I can say SYSO, I can go name, I can go SYSO address, I can go SYSO age, and I can change each of those things. So I'll change the name of Mary to Paddy. Okay. Now, when we're doing this, name, address, age, what we're actually accessing is this. Okay. It's the name of this object that's calling this method. Okay. It's the address of this object that's calling the method. It's the age of this object that's calling the method. Okay, so this is implicitly in front of all of those variables. Is that okay with everyone? Yeah? And you know what? Lunch. So, and we're back again. Okay, so we're doing about scope of variables. Okay, scope is just about what is available and when it's available. Now, so as I said, so we're accessing name, we're accessing address, we're accessing age. Okay, we can access any attributes in a instance method. Okay, so freeze. I'll just turn this on for a couple of minutes and then I'll turn it back. Okay, so here we're accessing name, and so all of these variables, all of the instance. So instant methods can access all static and non-static attributes of the local, the class local. Okay. Now, so I'm going to go down here to show you again more about local variables, and I'm going to declare double denum2 is equal to 3.45. Okay, now this is the local variable that is available only from this point onwards. Okay, now if I try to access denum even just above it, we get an error. Okay, the reason we get an error is because denum is a local variable and it's only available after you declare it. Okay, so now what we say here, we declare denum up here, so just go up a bit. There's denum. So could be asked the question, denum is longer than denum2. Okay, denum is longer than denum2. Okay, this line will not compile as said before. I'm just going to say it again. Forward referencing to local variables is not allowed. can't access denom2 before it is cleared. Now, anything that's outside here in this, now the scope of something. So that means that all attributes are available everywhere within the class. Okay, so age, for instance, is available everywhere in local. Yeah, do we understand that? Okay, right. Now, you can have brackets inside brackets. So let's just say we go, where am I here now? I'm going to clear a new cache. Okay, now I'm going to go here if age is greater than 19, and it is, okay, because you can see it here. Yes, yeah, so this if statement will enter. Now, inside these brackets, everything that's available, so all local variables that are declared outside of this if statement before it was created are available. Okay, so inside these brackets here, it has access to this guy, it has access to this lad, it also has access to denom, it also has access to name, address, and age. Okay, so it's access to everything outside it. Do you understand that? Right, say it again. Okay, so the local variables inside this method are, now num is a method parameter. Okay, so that's available throughout the method. Okay, and we've got a couple of local variables. Okay, the local variables are denom, double num, double number, and denom2. Okay, so in my if statement here, all of these variables, along with this new cache, are all available inside here. Do you understand that?
The new cache is because it's in the same package that you could do that, is it? That you could
Yeah. There's a cache in the same package. Okay. So all of these variables, num, denom, double number, denom, and new cache, they're all available inside here, along with age, name, and address. Yes, do we understand that? Okay. Now, so everything that's available outside of these curly brackets is also available inside here. Yes? Now, however, we can also create variables that are local to this if statement. So I'm going to do that. So I'm going to create a variable, and I'm going to call weight is equal to 34.5. Okay, now, so this is a local variable. That is only available inside curly brackets of the if statement. Now, we can access, just to prove that we can access denom2, we can access denom, we can also access cache. Okay, so okay, now if we attempt to access weight outside of the if statement. Okay, so hold on a minute. No, it's okay. If I try to access the weight outside of the local method, we get an error. Does everyone understand that? Because weight is local to the if statement. Yeah? Now, here's the thing. I'm going to scroll up the screen a bit here. So we see that denum2 is equal to 3.45. Now, that means we can access it inside here. If I change denum inside here, or denum2, it makes sense that if I change it inside these brackets, it'll also be changed outside the brackets. Does everyone understand that? Okay, so
No.
I'll explain it now in a minute.
Local only.
Now, hold on. So, denum2. Now, this is a local variable, but it's local to the method. Okay? It's local to the method. That means you can access it anywhere inside the method. We're still inside the method here. Okay?
Sorry.
Yeah.
No problem. Actually, it will be change it in void access local inside.
Yeah.
But
So,
not outside.
you can't access it outside. Okay? So, denum2. Okay? So, this changes the number to 6.9. Oh no, huh?
Is that denum2 that should be here? Is it?
Yeah, should be. Okay, right. So that means if I access it outside of the loop, oops, sorry, I have to run this. Hold on a second. Yeah, so just give me a minute now. I have to create an object of the local class. Hold on a minute. So I go local, my local is equal to new local, and then we go my local dot access local, send to number 4. There it is, 6.9. Okay, so
Just hold on. Main.
yeah, you need to create a local object, and then you need to call so I called my local, and then you're calling the access local method. So I go back to the local. So can't access weight. As weight is local to the if brackets. So it's the curly brackets. It's not the if statement. It's not the fact that it's a loop. It's not the fact that it's an enum. It's the fact of brackets, curly brackets. If you define a variable inside curly brackets, it means it's only available inside those curly brackets. Okay? Now, if we had another set of curly brackets inside the if statement, let's say in there, now that means that the if statement would have access, so these curly brackets would have access to weight, but we could create another local variable inside there that's not available outside here. Do you understand me? What I'm saying? I'm not sure what I mean. I am recording it. Now, so see what I've done there now. So this is the if statement. Alright? So it goes from here to here. And inside the if statement, you can do something like that. Alright? There's nothing stopping you from doing that. If you want to create local variables, you can do that. Change that. Alright? Now, new int is local to these brackets. So if we try to access it outside the brackets, so we're in the if statement here, we're not inside these two curly brackets, I can't access it. Okay? The other way around is I declare a weight here. Okay? We can access the weight inside here. See what I mean? Okay, weight is outside here, but this is another set of curly brackets inside the if statement. So that means all local variables of the if statement are available to this guy here. Now this variable here, this is local to these curly brackets. So you can't access it outside of these curly brackets. Any questions on that? Okay, so it's a question of you have your brackets. Now, age will be available everywhere in those brackets. If I have a set of brackets inside that, and we have string name, age is available inside here, but name is only available inside here. It's not available outside of its own curly brackets. Do you understand that? Okay. Isn't that opposite to PHP, isn't it? If you can remember it. Remember PHP? Wasn't that the opposite way of PHP?
Yeah.
Yeah, it was.
Ins and outs.
No, it's such a shite. Okay. So that's one thing you need to remember. You need to know if you declare something inside curly brackets, it's available throughout those curly brackets only. So for instance here, weight is available all the way of the if statement. Okay. New int is available only in here. But our weight is available inside here. Is everyone okay with that? Yeah? So let's take that out, type in a bit. So new int, this variable is local to this set of curly brackets, which are inside if statement, curly brackets. Okay. And here we can access the variables. I think this is the term used of the enclosing scope. I think that's the right term. Okay. Weight was declared in the if statement, which encloses these two brackets. Okay. So the enclosing scope of that is the if statement. Alright, so the weight was declared in the if statement, so we can access the weight statement in here. Okay, we can't access new int. As this is local to the above curly brackets. Now that code will just run, okay, but you can put something like that in the middle of your code. What will that do? That will create, what you can do in that situation, you can create variables that are not going to be accessible outside of those curly brackets. So if you want to do a piece of code that you want to remain anonymous, that you want to remain secret, just put brackets around it. And all those variables will not be available outside of those brackets. Does everyone understand that? Yes? Okay, so you can just do that. There's nothing doing with that. The code will just go straight into it. But new int is available, is not available outside of those curly brackets. So it's kind of like a security feature, you could say. Okay. And you can't access wait, because wait is local to the if statement, so you can't access that guy. Can't access new int because it's local to these curly brackets. Can't access wait as it's local to the if statement, and this is the end of the if statement. Is everyone alright so far? Yep, that absolutely okay. Now, so we're going to do a couple more examples of different sorts of locals. Okay, so we've all seen this already. For int I is equal to 0, I is less than 4, I plus plus. Now,
Still in the method.
yeah, it's inside the method. Let's make sure I am. I am, yeah. Okay, so this is int of access local method. Nice. Now, when you do this, I don't know if I said this before, but this creates a local variable. Okay, what you're doing here is you're creating a local variable called I, and it's an int, and it's not available outside of for loop. Okay, now it's preferable to do this than to do this. Okay, you can do that. Int I is equal to 0 for I is equal to 0. The reason why it's preferable to do this than have your variable defined before you go into it, it's because I is outside of the for loop. That means something outside the for loop can change I. Alright? Whereas if you declare it as a local variable, nothing can change I outside of the for loop. Okay, so it's usually preferable to have your loop like that. Usually preferable to declare a variable and have that as a counter, because this is your counter. Remember counters? So this is your counter. When you're using a for loop, now not in all situations, but in the majority of cases, it's better to do that than to do this. Okay, because what happens outside the loop can affect I. That's the basic reason why you don't do that. Okay, so
You just don't know in that forward, you probably can't just say I without saying equal to 0.
right, so if you have int I,
Yeah.
okay,
You just define
then you can go.
I.
Actually, you can't. You have to give it a value inside it.
Yeah, I just think
Kicks it.
Huh?
Kicks it off, doesn't
It does, yeah. There. Actually, you can do that. In actual fact, now we'll do this when you come to loops. You don't need anything in it.
What's that?
That's the for loop. All of those are optional
For what iteration?
for an infinite amount of iterations. So let's say if you can do this. I is less than 4. I plus plus. So here and there you can.
Yeah, that's okay, yeah.
Okay, there starts off at 0. But the problem with that is that I can be accessed outside of the for loop. So that means something outside the loop can change I. Could change I to 45. It could change I to minus 50. Alright? Now, we will be coming to that when we come to loops. Okay? So, I'll just put this guy in here. And I is equal to 0. Okay? I'm going to comment out that guy. Now, so the variable I is only available within the for loop curly brackets. Okay, so we can access it. Now, we can also do things like this. So, when I is less than 2, do the following. Alright, so I'm going to put in an if statement. If I is less than 2. So it starts off with 0 and 1. So it will do this. I is 0 and I is 1. Okay, so what I'm going to do here, inside here, I'm going to create a local variable j. So I'm going to say int j is equal to 4. And then we will go j is plus j, who we can also access I. So I'll put in a comment here. I'm just showing you local variables. Local variable j, which is only available within the if statement curly brackets. Now, every variable outside of these curly brackets is available within here. So you can't access j outside here. Can't access that. And you can't access I outside of the for loop. Okay, so I can't access j outside of the if. So count that guy out. And can't access the I. So comment out that guy. Now I'm just going to do another method here. So I'm going to go void accept method. So int num double denum. So method parameters are accessible only in the method that defines them. Scope, say this again, scope of the method parameter may be as long as that of a local variable or longer, but it can never be shorter. So if I declare a variable inside here, int local int is equal to 23. Local int has the same length as num and denum. Do you understand that? Okay. So local int has the same length as the method parameters num and denum.
But when they not be seen before though.
Sorry?
They may not be seen before.
They can be seen before it, but in this instance they can be seen before it. Well, yeah, but we're not seeing them. You know, we didn't put them in. You know,
Yes, yeah.
you only can see it when you actually type it in. You get me?
Yeah.
So yes, they can be seen, but you only see it the length if they're actually there. Do you know what I mean? They have greater retention length. I suppose that's what's great. All right. So local int, num, and denum, the situation all have the same length.
So there is some like how it's gonna be like double is bigger.
No. When I'm talking about length, it's where they're available.
Ah.
Okay. So length means where they're available. All right. So num goes from here to here. Okay. Well, actually, it's from here. Well, yeah. From the start of the method, the first line of the method has a local int. So that means that num, denum, and local int all have the same length. They're all available everywhere within that method. Yeah? Do you understand that? Right. So just to prove that you can access them all, I'll just do a simple print statement. I'll go num plus denum plus local int. Now that'll add them all up. But we don't care. Okay? Actually, we do care. So I'll just put in that in between each one of them. Alright, that'll ensure it will display whatever this number is, and it'll display 23. Yes? Okay, it has access to all of these. It also has access to name. Okay, it also has access to name. Now, so I'll just put in the comment here before we put in. So, a non-static method can access both statics and non-statics. Okay, so I'll just quickly create a method called void access static. So we can access instance variables. We can also access static variables. Okay, so that's an instance variable. This is a static variable. Now, put it in here. A static method can only directly access statics, so we can't access the attributes such as name, address, and age in this method. Okay, So so I'm going to create a method here. It's going to be a static method. Static void access static. That's why so. It's not access static 2. So course ID, we can access it directly. Okay. Now we can't access name. We can't access address. We can't access weight. Okay, so just comment 3 of them out. Can only access statics. Can't access non-statics. So if you want to get access to a name, an address, and weight, the only way you can do it inside a static method is create an instance of the class. So you go local, my local, say to new local, and then you go my local dot name, my local dot address, and my local dot age. Okay, so the only way to access non-static variables in a static method is to create a object of the class and access the attributes through the object. Now when you're inside a static method, of course you can do this. You can create int number. Nothing's stopping you to do that. Okay? You can create local variables inside a static. What I'm saying is you can only access static attributes. Okay? Whereas inside an instance method, you can access both statics and non-statics. That's why when we're in main, okay, I'm just going to go to main a second. Why? When we started off, you're only creating objects inside main. Now, I don't have any attributes of the main class. We couldn't access them anyway because this is a static method. Public static void main string args. Okay, any questions on that? No? Okay.
One question.
Yep.
It's not if you've got, say, the formula, you've got int I, right?
Yep.
You can't have int I anywhere else outside that loop.
Yes, you can. Yes, you can. Right. Let me just see. Do I cover that?
Does it not clash or something?
No, they don't, believe it or not. Okay, I just want to make sure now that I have it here. Okay, I don't have it, so I'll cover it here. Right. I'll create another method. And I'm going to call this void, what do I call it? Clashing. Let's say I go int I is equal to 0. Okay. And let's say I go for int j is equal. So hold on, Kieran.
Int I,
Yeah, j plus plus. So you're saying I can't create an int I inside here? No, you
so
can't.
the J
No.
from I in here would tend to
Oh well, I mean, if I did int
I there again.
I then no, you can't do that.
So
Okay.
anywhere in that you know you have say int I once is
No. Okay. There is an exception. Okay. There's something called shadowing. Which I'm going to show you. I don't need that method at all. Get it out. Now, but before I do that,
You're moving with caution.
sorry. Oh, I'm not doing clashing. I'm not going to do it, okay? Because there's something called shadowing, which I'm going to cover with the phone class, okay? But I'm not going to do that quite yet. So, I want to go to main, and we've created a local object. I want to create a second local object. So my local 2. Now we're going to change the addresses of both of these locals. So I'm going to say my local dot address is equal to Dublin, and my local dot address is equal to Cork. So just showing you how to access them. So, oh yeah, thanks, sir. So that means to access a attribute of a class, very simple, address of for my local is plus my local dot address. Now, just before I go on to the next one, I can access the address, but I can't access the name. See that? Why can't I access the name? Because it's private. Okay, I can access the address because it's protected. Okay, so that's why I'm using address and not the name. Age, which is down at the very bottom, is default, so I could have used age as well. Alright, but my local address, so that's going to print off Dublin. This one. Now, of course, you can access, you can access a static method the same way. So this is accessing a static method in a non-static way. So accessing a static attribute in a non-static way, which is through an object of the class. So, as I said to you many times, which is not recommended. Jesus, tomorrow's Friday. I kept thinking today is Wednesday or Tuesday. I don't know why. Well, time is really flying. Okay. So I go my local dot course ID, my local 2 should be in the print statement. Okay, that's going to be the same thing. Okay, it's going to be the same thing, which is 68965. 78965. 78965. Okay, so this is 78965, and this is going to be 78965. Okay, now if one local changes it, it's changed for all of them. Okay, so it's not recommended to access a static variable in a non-static way. What you should do is access it in a static way. Which is name of the class followed by static variable name. So we go here, accessing in static way. This is my local dot, oh no, it's local dot,
It push my local again.
sorry,
It has my local.
yeah, it is too, sorry, take it off. So name of the class followed by the, because if you do it that way, it's too easy to confuse it with an ordinary instance variable. Okay, that's why they don't recommend doing it. Now, so I'm going to quickly go to pupil class.
Yes, quicker.
Quickly go for a fag. Right, so pupil class. So I want to do the following: the pupil. I want you to create a string name, int age, static int course ID is equal to 3456. Okay, so we are public class pupil. So we're going to have a constructor for this class. Pupil, string name, int age, and this dot age is equal to age. This dot name is equal to name. We're going to have an eat method. And you can access both instance variables and static variables in this method. So we can do this. So name is name. Age is age. And course ID is, next line, plus course ID. Okay, so what we're doing, we're accessing both statics and non-statics inside a non-static method. Okay, or you can call it an instance method if you want. So accessing static and non-static attributes inside this non-static method. Now, end of method. The primary function of static methods is so you can access static variables. Okay? So static void take course. So this is a method that applies to everyone in the course. Okay? So if we're talking about everyone, we can say we are taking the course with ID of plus course ID. Now we can access those guys, but we can't access the non-statics. So name. Okay. I don't think we really need to create a student to reiterate the point. Okay. So the correct way to call this method would be, so I'll just do that. So the correct way to call the take course method would be pupil dot take course. Okay, so the correct way to call a static method is through the class name. Okay, so again, calling static method in a static way. Now, static methods are also called class methods. Static variables are also called class variables. Now, so the only new thing that's covered in all of this is the following. Okay, so a couple of rules when declaring variables. Okay, first rule: can't have two variables of the same name. Okay, now there is exceptions to this. Generally, you can't have two variables of the same name, even if one is static and the other is an instant variable. Okay, so I can go string name is equal to Apple. I can't go static string name is equal to Samsung. Okay, so this does not compile. Now, can't have two variables of the same name, even if one is static and another is an instance variable in the same scope. Okay. Actually, no, I'll take that out. Right. Now, so every phone, we're assuming this is for Apple, the iPhone. Okay. And I don't know, there's probably 3 or 4 different iPhones. So we're going to say this, when they're creating the software for their iPhones, we're going to say this is going to be for the Samsung or the Apple iPhone S or whatever the fuck they're called. Okay, iPhone X, I think, something like that they're called. Alright, so they're all going to have a model ID. So they're all going to have the same model ID. It's going to be equal to 122. So every phone will have this model ID. Okay, if I go static string color is equal to black, every phone will be black. And another one again here. Can't have two variables. with same name, even if different types. Okay, different data types. For instance, I could do double weight is equal to 45 point or 1.2. I can't go okay. Now this guy here is a double. This guy here is an array. Okay. You can't have two variables the one same. Now, so if you know that rule, okay. Another thing. Alright, if I create a method called dial. Now again, this makes sense really. So int number. Okay. Now, if I try to do this, this makes sense. You can't have a local variable with the same name as a method parameter, which makes sense. How does it differentiate between the two of them? Okay. You can't have a local variable with the same name as a method parameter.
But could you have an int number and a double number as a local variable too?
You mean like that?
Int number and double number.
You mean in the method parameters?
Not in the parameters, in actually either in the parameters or below.
Well, right, so
Int number, double
yeah,
number.
hold on a second. Right, so doesn't matter what the data type, doesn't matter. Number one, okay, it could be anything. It could be a banana. Okay, doesn't matter what it is. Right. The simple fact is you can't have a variable inside here called number. Okay, because the method parameter. Now, what I mean by local, it's local to dial up. All right. So the method parameter, one of the parameters is called number for dial up. That means a local variable inside the dial up method can't be called number. Does that make sense? Yeah. Okay. Now, so that's about. So I'm going to comment out that guy. So this guy doesn't work. Now I'm leading up to something called shadowing. I just probably just get it to show you today, nothing else. Okay, so if I go, I'm going to create a right dial up, void dial up, and we're going to access the name of the phone. So we're going to access the name of the phone inside here. I'm going to access the weight. Now, this applies only to attributes of a class, okay? I'm going to show you now it's about attributes of a class. So the weight of a phone, it doesn't matter if they're static or non-static. Okay, so this only applies to attributes. So the name of your phone, the ID of your phone, the color of your phone, the weight of your phone. I'm going to deal first with instance attributes, ordinary attributes of a phone. Okay, so name up here is a string. Now we don't get an error. See that? We have a name created, an attribute. Okay? Here, now what we're doing here is we're creating a local variable called name. And it's a string. Alright? Now what actually happens here, what's happening here is something called shadowing. Alright? What actually happens is, so just to show you what happens, I create a phone and I call this method. Okay? So I'm just going to quickly create a phone. I just want to get this to show you before the end of today. So I'll create a phone. And I'm going to go right. So dial up. So what happens is name of phone. So it's getting the attribute of the phone. One of the attributes is a string, a name. It prints off Apple. Okay. It's getting the weight of the phone. The weight is an attribute of the phone. It'll print off 1.2. Now what we're doing here is we are creating a local variable of the same name, as the same name as one of the attributes of a class. And what happens is something called shadowing. Okay. Now, what's actually happening is that this name is hiding the other name. That's basically it. It's like it's standing in front of it.
What did you put in?
What did I put where?
The other name.
The other name is Apple. Okay.
This one you're calling is the apple,
Apple, yeah.
which is defined.
Yeah. Okay. So this name here, so I'll put the comment. This name here is the name attribute of the phone. Okay. This here is the local variable called name, which shadows the attribute name. Okay. Now I still wouldn't recommend you doing this. Alright? Just because you can do something doesn't mean you should do something. Okay? Because you can get confused. Okay? It's just as easy to call that something else. Local name. L name. Okay?
You could get something like that in exam, though.
Yes, of course, yeah. Actually, there's no could. You will. Sorry? What do you mean class variable? No. Class variable is a static variable. Okay? But you can call it something else. Alright? As I said, just because you can do something doesn't mean you should do something. I'm all for not making your life more difficult. This makes your life more difficult. I'm sure there is circumstances where it is useful to you, but in the vast majority of cases it isn't. Okay? But this is called shadowing. Okay? So I have a big comment and I'm just going to copy and paste the comment in and I'll read it out to you. And I'll upload the code and you can download it. Okay? So I will put it in here. Local variables, the same name as instance of class variables is allowed. Sorry, not class variables. Instance or class variables is allowed. This is called shadowing. Remember that the variable name and weight are local variables, meaning they only apply to inside these curly brackets. Okay, hold on a minute now. Okay, sorry, just take that out. That's the wrong explanation. Let's change that. Local variable. Okay. Right, so here's it. This is the local variable called name, which shadows the attribute name. Local variables with the same name as the instance, same name as instance or class variables is allowed. So both statics and non-statics. This is called shadowing. Remember that the variable string name is a local variable. So this is a local variable. Okay. When you put a data type in front of name, that becomes the local variable name. Okay, which is not the name, which is the attribute of the class. Okay, so if we choose to omit, so if I take out the string, hold on a minute now. So if I take out the word string, that no longer refers to a local variable. That refers to the name of the phone. Okay, but by putting string in here, we're creating a brand new variable called name, and it just happens to have the same name as one of the attributes of the class. So what in effect happens is that so from this point forward, anytime we mention the word name, we're talking about
String.
the local string name. Okay, so from this point forward, when we use name, we are talking about the local string name, not the attribute of the phone class called name. Now, if we want to attribute, so from this point forward, if we want to access the attribute, right? If I want to access the actual name of the phone, how do you think I would do it? I can't use name. What could I use instead? No, this. Okay, so if I go like this, this. So the name of the phone is, you go this.name. Okay, so if you want to access the name of the phone, the attribute of the phone, you have to use this. Is that okay? Now we're going to come back to this tomorrow. Now, as I said, just because you can, you need to know this for the exam, right? But be very wary of doing this in real life because it's too confusing.
When you change string name from Samsung,
Yeah.
that only applies within the, so it doesn't change the name outside.
No, it doesn't, which is what I'm going to show you tomorrow. Okay? I'm going to show you that tomorrow.
Everything would happen with the brackets, curly brackets, staying curly brackets.
Yeah, that's probably one way of putting it. Yeah. Actually, no. That's not true.
Come on, they say yes.
The stuff does happen inside curly brackets. It does affect what happens outside it. Okay?
And no, just further up there, just a few dots up there.
Yeah.
Up another. Okay, yeah. So you could double it, oh yeah. Just down small bit.
Down or up?
Down. Equals. it's where you're using double. No, you were saying the parameter can't be the same.
Oh, here.
The declaration.
Yeah, here.
Yeah, there, right?
There, yeah.
Yeah. Now, could you have a double number somewhere else? In the
Oh,
same.
well, I mean,
Well,
right. What you can have is you can have this. And so I'll just take this guy out. Yeah, you can have that.
But could you have on line 31 there, it's got the two slashes. Could
Oh.
you have two
No.
doubles, one inside and one outside? And they're-
No. No. Well, no. See, what's wrong with this is that clashes with that,
Oh, I understand that, John.
Yeah. but it doesn't clash with that. Because all that happens is that shadows that hides it.
Okay.
So I just change this to,
Okay, I can see that.
you know?
Yeah, I see what you mean.
Okay. So I'll just put this back to the other one. And I'll take out that guy. Okay. So I will explain more tomorrow about these guys. So take a break for a couple of minutes. Don't go yet though. Don't go yet. So I'll finish that. Okay, so this is section 2.1. Alright, so we're doing about the scope of variables. Okay, basically, if you declare something inside brackets, it's available everywhere within those brackets. Alright, so if you declare an attribute, that means it's available everywhere within the phone class. Alright, now I don't know if you've noticed these little dudes here. See them here on the side? You'll see little minus buttons appearing on the side. See them? If you want to, let's say, if you don't want the comments to appear, see them there? You can, or let's say I have a method here called dial up. I don't want to see all the details of dial up. There's a little minus button there. It's very small. You can barely see it. Click on it. So then dial up is hidden. Right? So now that is a useful enough feature. Let's say if you have a class and it's got 30 or 50 different methods in it. You don't want to see them all, you just want to see a list of them. You can expand them or you can collapse them. Alright? It's a handy little thing to notice. Okay? Similarly, if you've got multiple classes in the one file, you'll be able to expand and you'll be able to collapse the classes as well by using these little buttons here. Now sometimes Eclipse might automatically do that and you can't see them. Alright? It's not that you haven't deleted them, don't worry. Just look for the little plus button and they appear again. Is that okay? Alright? Now, of course that's not examinable, it's just some little handy feature of Eclipse. Now, so we have my pen. So I was explaining the concept of shadowing. Okay, so we have an attribute of the class and it's a string name. Okay, and we give it a name of apple. Okay, so that's an attribute of the class. So that means anywhere within the class, so from here to here, if we use the word name anywhere from the very top of our class to the end of our class, if we use name anywhere, what we're referring to the name of the phone, and it's going to be,
So it's a nice one.
Huh?
Very moving. So it's a nice one.
So it'll be referring to the name of the phone, which is Apple. Yeah? Ever understand that? So if I use name anywhere in this class, it's going to print out Apple. Right? Because I've given it the default value of Apple. Right? Now, I have a method called dialup. Okay? And inside dialup, I have name of phone is name. Now that's going to print Apple. Okay, and you can see here I've already run it. Name of phone is Apple. Yes? Okay. Name of weight of phone is, what did I say the weight was? I said the weight was 1.2. Yeah? Okay. So knowing I put name refers to the name of the phone, which is an Apple. It knows the weight, which is 1.2. Anywhere within the phone class. Now, you can, however, when you're talking about an attribute, now this is only the case with attributes. Okay, this does not work with local variables. Okay, we're inside the dial-up method. Inside the dial-up method, I create another variable of the same name and the same type. Okay, now what happens effectively is that from this point forward, inside the dial-up method, name is going to refer to Samsung. Okay, because this name is hiding the attribute name. Okay,
Sorry, no, at what point you give like string name equal Apple?
at the very top.
Yes, is it not better like string name and finish like this and it can be changed everywhere?
Oh yeah. Well, now you should have a constructor in this class. There's no doubt about that. Okay, you should have a constructor in the class where you're given it. All right, but I'm just trying to show you shadowing. Okay, so yes, this is not a good way. This is not a good way to have a class. Okay. Now, so I go down here again. So, string names equal Samsung. Now, that means from this point forward, only inside the dial-up method, okay, name is going to refer to Samsung. And you can see here, so name of shadow is Samsung. So if I use name in the rest of the dial-up method, name is going to mean Samsung. Now, if we want to refer to the attributes name, okay, the attribute of the class, we have to use the term this dot name. Okay, now what that means is, what is the name of the phone that is calling the dial-up method? The name of the phone that is calling the dial-up method is Apple. Okay, and this is the local variable name. It's not the name of the phone. Okay, now that's called shadowing. Now, as I've said, you can do that. Just because you can do something doesn't mean you should do something. Okay, I would recommend against doing that because it's confusing. Okay, it's not a good idea to have a local variable the same name as an attribute of a class. Okay, regardless whether you can do it. Now, there is going to be circumstances where you're going to use it, maybe, but by and large, it's a bad idea because it's confusing. Okay, anything that's confusing is a bad idea. Simple as that. All right. If something can be something else, then it's a bad idea. All right. Like most things in life. Any questions on that?
If you put phone instead of this there, would that work? No.
No, because it's not a static. If it was a static, yeah.
Fair enough,
Yeah. Any other questions? No. Okay. So this dot name will refer to the name of the phone, right? So this is local string name. This is the name of the phone that is calling the dial-up method, which is Apple. Okay, this is the name of the phone that is calling the dial-up method, which is Apple. Now, if the name of the phone was Huawei, or however you pronounce it, or what other phone brands are there? LG, Sony. What other phone makers are there? Nokia,
Xiaomi,
Motorola.
Xiaomi, Motorola. Okay. So You can go here, you can change the name of the phone, whatever. So whatever the name of the phone is, okay, this is what will print off. Now this name here, that is a local variable called name. Here, it's the name of the phone that is calling the dial-up method. Okay, hence the term this name. So it's the name of this phone. That's why they use the term this. Is everyone okay with that? Okay, now I'm going to scroll up the screen. Now I have a static string color is equal to black. Okay, C is black. Now, for a start anyway, a local variable can't be static. Alright? So a local variable can't be static. Now, you can access static variables inside a instance method. So if I just want to access the color, okay, you can do that. Okay, so this is accessing a static variable. In this method, in this dial-up method. Now, but whereas you can't create a static method, you can shadow it. Alright? Oh, what do I mean by that? I'm going to put it in brackets to start off. Alright? So these are brackets that are inside the dial-up method. Okay? So I can go string color is equal to blue. Now, I'm going to go here. So local color is that's color. That's going to print off blue. Does everyone understand that?
That's why I made like this bracket, because I actually put it in dial-up.
Yeah, I'm putting it in for a bracket for a minute for a reason. Okay, so I'm putting in those brackets for a reason. Okay. Now these brackets, that is fine. When you have brackets like that, all that happens is your code just keeps on going. Okay? It keeps on going. But remember, anything declared inside these brackets is local. Alright? So that's one of the reasons you'd use them. If you don't want this variable to be available outside of these brackets. Okay? Now, but you could have curly brackets in a for loop, in an if statement, in a switch statement, in all types of loops, in enums, in inner classes, whatever. Okay? So curly brackets. Now, so what's happening here is that this color here. Now, whereas you can't create a static variable inside a method, you can shadow it. Okay? Now what I mean here is that color is hiding this color. So what's printing off here is the local variable color. Is everyone with me there? Yeah? Now, but remember, it's local to these brackets. Alright? So that means as soon as I come outside it, it's now back to the phone color, which is black. Okay? So this guy here is now black, which is the color of the phone. This is a local color. So that it is. There it is. Local color is blue. Phone color black.
So you change it color, and after that you go in color again. It's
Well,
you not need this.
Well,
Not all.
no, because you've got your brackets.
Yes, it's back. No,
Yeah. So those do have their usages. So if you want to declare a variable that you don't want available, you don't want to accidentally change something, or you don't want this variable outside of a specified range, you just put in brackets. And that variable will only be available within those two brackets. Okay? Or, in this case, you're shadowing it. So color is going to be blue, so it's blue inside here. So that's just a local color. Outside of those brackets, it's going to be the color of the phone.
And sorry,
black.
we have no brackets. Can we name it? Or like you put
You mean to say, can you name this thing?
here?
You can. But we won't do that.
Ah.
Yes. Okay. You can actually name it.
Well, 977 there now.
Yep.
You have plus color and that works.
Yep.
Now you can need to put in the
This.
class name. Like
No,
what color, you couldn't
no,
really-
class name. You only put in class names. Oh, you could put in class name. Yeah, you could put in class
You
name.
didn't have to put it in.
No.
But is there a situation where you would have to put it in? I know that you don't have to put it in there, like, but is the situation there like when you do different statements that you would have to put in the
When you're inside the same class.
in the same class, yeah.
No. Well, you see, because we're inside the
yeah.
phone class, so you don't have to put in
Yeah.
the name of the class. But yeah, you could. You could go.
You could use this there because it's not it's a static, it's not
You actually can't.
yeah, I suppose you're right.
You can, because you're accessing the color in a non-static way. That's the exact same as you creating a phone, and then you're accessing the color of the phone through the phone. So you can use this, even though it's not a instance variable. Okay, I wouldn't recommend you using this with color. So what is going on here? So I'm going to put in a comment here. So I'll just go end of brackets. So it's end of local color blue. Okay, so I'm going to put in a comment. Okay, so you can't create a static variable inside a method. However, you can shadow a static. So color. So this local string color is shadowing the static string color. This color is local to just these curly brackets. I'm sure there's a right term for them, but that's what I call them, curly brackets. Okay, outside of these curly brackets, color refers to the color of the phone, which is black. Okay?
It's not, it doesn't, the shadowing variable isn't static as well, is it?
No, it's not. Okay, so this variable is not static. It's just hiding it.
Yeah.
That's all it's doing. It's like it's standing in front of the other one, so you can't see the other lead because I'm here. That's exactly what it's doing. Okay, you can see the other color. It's not static. Okay, does everyone understand that? Okay, now that is. So just go end of method. So I think that is. Just do one last method here. Sorry, I should have run this guy here. Sorry, hold on a minute. No, just again, I just want to. Yeah, sorry, Kieran, go on.
It's 1984, where you said you could use this, that color.
Yeah.
Would you haven't created an object on the phone there because you had no constructor. So I just
Well, no, you are creating a phone object. Alright? Just because there's no constructor there doesn't mean, I mean, this is a instance method, okay?
Yeah.
So you can't call this method unless you create a phone. And I have here, my phone is equal to new phone, my phone dot dialog. Okay? Now, if this was a static method, I don't need to create a phone. Alright? So let's just say if I have void stat method, I should have a print statement inside it. Static method called. I don't need to create a method. I don't need to create an object to call this method. All I have to do is go phone dot. Hold on. Static void. Sorry. It's a static method. You don't need to create a phone to call that method. So you go phone dot stat method. There it is. Okay. Static method called. Okay. So if the method is static, you don't have to create an object to call it. If the method is not static, you have to create a phone to call that method. Any questions on that?
So if you had created a phone there, if you hadn't created a phone, you couldn't use this.
No, you couldn't use dialog. No. Okay. So, but you could use stat method. Okay. Just like when we're going here, system.out.println, that is a static method. Okay. It's a static method of the out class. It's a class called out. Okay. It's in the system library. It's in the out class. There's a static method called println. So that's what you're doing there. You're calling a static method system.out.println. You don't have to create an out object to call the println method. Is that okay, everyone? Now, so that is that section done. So I'm going to